Okay, I believe everything is good. Change the thumbnail. Whoops. Let's copy that link. Come over here and paste it. Share it. And we're going. All right. How's everyone doing? Last time we were doing numbers, I believe. We got it to say a favorite number, yada yada yada. We went over the Zen of Python. We broke it down a bit. So today we're going to move on to chapter 3, working with lists. So lists are exactly like they sound. They are a list of values. So what is a list? A list is a collection of items in a particular order. You can make a list that includes the letters of the alphabet, the digits from 0 to 9, or the names of all the people in your family. You can put anything you want into a list, and the items in your list don't have to be related in any particular way. Because a list usually contains more than one element, it's a good idea to make the name of your list plural, such as letters, digits, or names. In Python, square brackets indicate a list, and individual elements in the list are separated by commas. Here's an example of a list that contains a few kinds of bicycles. Bikes or bicycles equals Trek, Cannondale, Redline, Specialized, Print, Bicycles. If you ask Python to print a list, Python returns its representation of the list, including the square brackets. Because this isn't the output you want your users to see, let's learn how to access the individual items in a list. So accessing elements in a list. Lists are ordered collections, so you can access any element in a list by telling Python the position or index of the item desired. To access an element in a list, write the name of the list followed by the index of the item enclosed in square brackets. For example, let's pull out the first bicycle in the list of bicycles. Print bicycles 0. When we ask for a single item from the list, Python returns just that element without the square brackets. This is the result you want your users to see: clean, neatly formatted output. You can also use the string methods from chapter 2 on any element in this list. For example, you can format the element Trek to look more presentable by using the title method. So print bicycles 0 dot title empty parentheses. This example produces the same output as the preceding example, except Trek is capitalized. Index positions start at 0, not 1. You might have noticed this would normally not be that. Python considers the first item in a list to be at position 0, not position 1. This is true of most programming languages, and the reason has to do with how the list operations are implemented at a lower level. If you're receiving unexpected results, ask yourself if you're making a simple but common off by 1 error. The second item in a list has an index of 1. Using this counting system, you can get any element you want from a list by subtracting 1 from its position in the list. For example, to access the fourth item in a list, you request the item at index 3. The following asks for the bicycles at index 1 and index 3. Bicycles 1, bicycles 3. This code returns the second and fourth bicycles in the list, so this one and this one, Cannondale, specialized. Python has a special syntax for accessing the last element in a list. If you ask for the item at index -1, Python always returns the last item in the list. So this code returns the value specialized. This syntax is quite useful because you often want to access the last items in a list without knowing exactly how long the list is. This convention ends to other negative index values as well. The index -2 returns the second item from the end of the list. The index -3 returns the third item from the end, and so forth. Using individual values from a list, you can use individual values from a list just as you would any other variable. For example, you can use f strings to create a message based on a value from a list. Let's try pulling the first bicycle from the list and composing a message using that value. So message f string My bicycle was a bracket bicycles 0 dot title empty parentheses print message. We build a sentence using the value at bicycle 0 and assign it to the variable message. This output is a simple sentence, but the first bicycle in the list. Oh, about. It's not but, sorry. My first bicycle was a Trek. All right. So now we'll finally get on to the coding portion. Let's make a new file. And then we'll name it. And we will finally be moving on from PCC 2. We're now on PCC 3 underscore 1. Okay. And then we're gonna comment it like how we did last time. Today is the 19th. Oh, not the 2023 anymore. And now we can start our code. So let's try these short programs to get some first-hand experience. Python's list. You might want to create a new folder for each chapter's exercises. We will not be doing that. To keep them organized. Names. Store the names of a few of your friends in a list called names. Print each person's name by accessing each element in the list one at a time. Okay. We're not going to do names of people though. We are going to be doing names of Pokemon. So we're going to do Pikachu. Just do all the Kanto starters. Bulbasaur. Squirtle. Charmander. So this is our list. And to get everything out, we're going to say print. And then we are going to tell it to print names. And then we're going to tell it 0. And now all we're going to do is we're going to copy and paste this on a new line. New line. New line. And then we're just going to change the values of this. And then since we only have 4 things, we are going up to the number 3. So now when we save this and run it, it should give us... Oh, these need to have the quote marks. Anything that's a string needs to be in quotes. Kind of forgot that for a second. Okay, let's try this again. Boom. Pikachu, Bulbasaur, Squirtle, Charmander. Alright. So let's move on. Start a new file. We shall name it PCC 3 underscore 2. Okay. Let's comment it out. Oh. You know what we didn't do? We didn't come over here and we didn't do another comment. So this is going to be called Pokemon names. And then what we can do is we'll label this name accessing. You know, brief description. This is exactly what it sounds like. This is exactly what it sounds like. Let's also add output. All right. Let's save that. And then let's come back in here. Cannot eat 2-19-24. All right. So greetings. Start with the list you used in exercise 3.1, but instead of just printing each person's name, print a message to them. The text of each message should be the same, but each message should be personalized with the person's name. Okay, simple enough. So we're gonna come over here. We're just gonna copy this, and then we're gonna come in, insert that in, and then we are going to name this part or comment on this part of the code and say that this is a battle start dialogue or expression, whatever. I think you know where I'm going from here. And then we're going to call it, or why don't we just make this simple and say it message. And then we're going to start a new variable, and we are going to do F, and then we are going to say brackets, names, and then we are going to do 0, and then we're going to add a comma at the end of that, and then we are going to say oh, that's still within this, whoops, comma, I choose you. Okay, now we're gonna copy this again. Oh, wait. Is there a different way to go about this? I was gonna copy and paste this and then just like rename the variable, but we are going to say that has nothing in it. We're just gonna leave this blank because there should be no space after this, after I say print. So we're gonna try this out here. We're gonna come down and say print, and then we're going to tell it to print names, and then we're going to tell it which name to do. So we're going to do it at value 0, and then and then message. No, that doesn't work. What if I put a comma here? I don't know if that's going to add a secondary thing. Okay, let's take this out. That should correctly print this out. So we're just going to save it for one thing instead of doing it all same and then it being wrong. So let's run it without debugging. Oh. Pikachu, I choose you. Okay, so there's no comma. So that comma does nothing. So let's add that back in and then save it and then run it again. Okay, so there is blank space here. What if I do that? What does that change? If it changes anything. It changes nothing. Okay. Maybe I would just have to put a comma in the back of their names, but then if I wanted to use this list for anything other than this specific greeting, it would have a comma at the end of their name. So I don't really want to do that. Yeah. Because if I put this in here, it's either going to give me this entire list, or if I specify it, it's going to give me something else. And instead of creating a new message for each one, I want to reuse this instead of doing this. Okay, so this has to have been in an example, right? Oh my god, everyone's dog. Let's look for where we can find this example. Um, okay, this doesn't really do a good job at trying to say what I needed to say. So what we're gonna do is we're gonna change this to say message one, and then we're actually gonna move this. So this is just gonna say message one, and then we're gonna actually put no our names. I mean names, and then position 0. Okay. So let's save that. Now let's run it. So now the comma is in the correct place and the stuff. So we're going to change that comma to say messages. And then we are going to come over here. And then we're going to paste it, paste it, paste it. And then we're going to just change all the values and be done with this. Uh-huh. 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 Okay. So that should adequately do that. So what we're going to do is we're going to actually come down and then we're going to make another one. And then we're going to say message outputs. Okay. Put that back. And then we're going to just paste this over and over. And then we're just going to change these. And then when we save it, it should run correctly. All right, so we did it. And then we can also do this dot title if we really wanted to. Just so it looks a little prettier. Okay. Oh, I think I wrote that on the wrong side. Yeah. Right. Let's see if we messed it up. Nope. Now it looks good. So that is example 2 done. Greetings. And now we will be making our own list, it seems. Okay, let's rename it. And then we're going to comment. Okay. Your own list. Think of your favorite mode of transportation, such as a motorcycle or a car, and make a list that stores several examples. Use your list to print a series of statements about these items, such as I would like to own a Honda motorcycle. Okay. So let's do that. We're gonna come down and then we're gonna say this is a list of cars I like, and then we're gonna just call this variable cars, and then we are going to equate it to we're gonna put my car first, Corolla. Then we will put a GT3. It's a Porsche. Not the RS. I feel like the RS is a little overplayed. It's a nice car, don't get me wrong. And I would love to own one given the opportunity, but I'd kind of rather just have the GT3. And then, let's see, last car. Why don't we do something more obtainable, like a Miata? Okay. And then user list to print a series of statements about these items. And then we are going to call this car statements. Okay. And then our statement. And then we're just going to say statement is equal to F. I would love to own a, and then we're going to do statements, and then change that to statement 1, a, cars, or sorry, it needs to be brackets, cars, and then position 1, or 0, I mean, 0, and then come to the outside of that, dot title, empty parentheses. Now we can copy this, paste it a few times, change it, come down here, same thing, and then we'll come down, and then we're going to say print statements, and then we're just going to do print function, and then we are going to say statement 1, oops, 1, and then just copy and paste it. And now if we save this and run it, it should give us our output. Yep, I would love to own a GR Corolla, I would love to own a GT3, and I would love to own a Miata. All right, simple enough, right? So now moving on, modifying, adding, and removing elements of the list. Most lists you create will be dynamic, meaning you'll build a list and then add and remove elements from it as your program runs its course. For example, you might create a game in which a player has to shoot aliens out of the sky. Galaga. You could store the initial set of aliens in a list and then remove an alien from the list each time one is shot down. Each time a new alien appears on the screen, you add it to the list. Your list of aliens will increase and decrease in length throughout the course of the game. Modifying elements in a list. The syntax for modifying an element is similar to the syntax for accessing an element in a list. To change an element, use the name of the list followed by the index of the element you want to change, and then provide the new value you want the item to have. For example, say we have a list of motorcycles and the first item in the list is Honda. We can change the value of this first item after the list has been created. So that looks like this. If it's Honda and then you say motorcycle 0, so this is equal to Ducati. You're basically just redefining it. So here we define the list of motorcycles with Honda as the first element, and we change the value of the first item to Ducati. The output shows that the first item has been changed while the rest of the lines stay the same. So that's this line of code right here. And then when you do this underneath and it prints again, it'll look like that. So you can change the value of any item on the list, not just the first item. Adding elements to a list. You might want to add a new element to a list for many reasons. For example, you might want to make new aliens appear in a game, add new data to a visualization, or add new registered users to a website you've built. Python provides several ways to add new data to existing lists. So that would be called appending an element to the end of a list, or you can do it to the beginning as well. The simplest way to add a new element to a list is to append the item to the list. When you append an item to a list, the new element is added to the end of the list. Using the same list we had in the previous example, we'll add the new element Ducati to the end of the list. Here, the append method works or adds Ducati to the end of the list without affecting any of the other elements in the list. So you would do that like this, motorcycles.append Ducati. And then when you print it, it just adds on. The append method makes it easy to build lists dynamically. For example, you can start with an empty list and then add items to the list using a series of append calls. Using the empty list, let's add the elements Honda, Yamaha, and Suzuki to the list. So have a blank list here, and then by the time you get to the very end, this is the output you get. So it's also useful for building stuff like a user base where you just have everyone's usernames stored on a single file that you can then use to draw from later. And every time someone adds a new username, it just gets put into an append statement and gets added to your list. Building your list this way is very common because you often won't know the data your users want to store in a program until after the program is running. To put your users in control, start by defining an empty list that will hold the user's values, then append each new value provided to the list you just created. So inserting elements to list, you can add a new element to any position in your list by using the insert method. You do this by specifying the index of the new element and the value of the new items. So insert 0, Ducati. So one thing to note is that it does not delete what is there. Instead, it just pushes everything one back from whatever value you put in. In this example, we insert the value Ducati at the beginning of the list. The insert method opens a space at position 0 and stores the value Ducati at that location. The operation shifts every other value in the line one position to the right. To remove elements from a list, often you'll want to remove an item or a set of items from a list. For example, when a player shoots down an alien from the sky, you'll most likely want to remove it from the list of active aliens. Or when a user decides to cancel their account on a web application you created, you want to remove that user from the list of active users. You can remove an item according to its position in the list or according to its value. You can remove items using a delete statement. If you know the position of the item you want to remove from a list, you can use the delete statement. So you have your list here, and then you say to delete the first item. So here we use the del statement to remove the first item, Honda, from the list of motorcycles. You end up with just Yamaha, Suzuki. You can remove an item from any position in the list using the del statement if you know its index. For example, here's how to remove the second item, Yamaha, from the list. Exact same thing, you just put in a different index number. Second motorcycle to delete from the list. In both examples, you can no longer access the values that was removed from the list after the del statement is used. Removing an item using the pop method. Sometimes you'll want to use the value of an item after you remove it from a list. For example, you might want to get the X and Y position of an alien that was just shot down, so you can draw an explosion at that position. In a web application, you might want to remove a user from a list of active members and then add that user to a list of inactive members. The pop method removes the last item in a list, but it lets you work with that item after removing it. The term pop comes from thinking of a list as a stack of items and popping one item off the top of the stack. Never really heard anyone saying popping off the top of like a stack of things. I've always heard take one off the top, but not really pop off the top. Anyway, that was a bit of a tangent. Where was I? In this analogy, the top of a stack corresponds to the end of a list. Let's pop a motorcycle from the list of motorcycles. So it'll automatically pop the last item of the list. So from this list, it should pop off Suzuki. And if you go down here, you can see that it popped off Suzuki. And then if you wanted to show that, you would use print popped motorcycle. So after you pop something, to recall that information, you have to say popped. So we start by defining and printing a list of motorcycles. Then we pop a value from the list and assign that value to the variable pop motorcycle. We print the list to show that the value has been removed from the list. Then we print the pop value to prove that we still have access to the value that was removed. The output shows that the value Suzuki was removed from the end of the list and is now assigned to the variable pop motorcycle. How might this pop method be useful? Imagine that the motorcycles in the list are stored in chronological order according to when we owned them. If this is the case, we can use the pop method to print a statement about the last motorcycle we bought. The output is a simple sentence about the most recent motorcycle we owned. Popping items from any position in a list. You can use pop to remove an item from any position in a list, including the index of the item you want to remove in parentheses. So pop 0, it's popping off Honda. Then you can say print and then first own dot title. So first own dot title, and then it should give you Honda. So we start by popping the first motorcycle in the list, then we print a message about that motorcycle. The output is a simple sentence describing the first motorcycle I ever owned. Remember that each time you use pop, the item you work with is no longer stored in the list. If you're unsure whether to use the del statement or the pop method, here's a simple way to decide when you want to delete an item from a list and not use that item in any way. Use del statement. If you want to use an item as you remove it, use the pop method. Kind of self-explanatory, is it not? This is a lot of talking. Removing an item by value. Sometimes you won't know the position of the value you want to remove from a list. If you only know the value of the item you want to remove, you can use the remove method. So like, let's say that you wanted to remove Yamaha, but you didn't know which position it was in. So you would have your list, and then you would say remove, and then give the actual name of the value. So like, if it's not a number, you give back this. Use the remove method. Basically, if it's a string, and keep in mind, numbers can be in strings, so as long as it's a string, you can use it to remove something somewhere within that list without knowing where it is. Here, the remove method tells Python to figure out where Ducati appears in the list and remove the element. You can also use the remove method to work with a value that's being removed from a list. Let's remove the value Ducati and print a reason for removing it from the list. Too expensive equals Ducati, motorcycles that remove, too expensive. That's a very complicated way to do that, I guess. Just to say that it's expensive again. So like, the people are never going to see this part. And if you're also going to say what it is in here, you do not need to do this. You can literally just skip that step and do this. This makes more sense. I don't know why he decided to add in extra lines when writing this part. Maybe someone more experienced could explain, but this is dumb to me. This is unnecessary work you are making for yourself here. So after defining the list, we assign the value Ducati to a variable called tooExpensive. We then use this variable to tell Python which value to remove from the list. The value Ducati has been removed from the list, but is still accessible through the variable tooExpensive, allowing us to print a statement about why we moved Ducati from the list of motorcycles. Okay, but if you're removing it from the list and you don't need to, I guess if you don't know where it is, you would need to do it this way instead of using the pop function. So I guess that's a reason why you would do it this way, but I still don't agree with how it's written. And if you're asking me for an alternate solution, I'm not going to make one right now. That's more thinking than I need to do. So the remove method deletes only the first occurrence of the value you specify. If there's a possibility the value appears more than once in the list, you'll need to use a loop to make sure that all occurrences of the value are removed. You'll learn how to do this in chapter 7. Loops are confusing. That's something genuinely confusing. So the following exercises are a bit more complex than those in chapter 2, but they give you an opportunity to use lists in all of the ways described. we are only going to go up to this, or should we just finish out the list? But because this is already getting kind of long for this stream, so we'll at least do up to 6, and if it's going on a little bit too long, we'll just cut it and then finish the chapter next time. Because I believe 6 is halfway through. Oh, 4. Not 6. Okay. Guest list. Okay. So let's make a list called guess. If you could invite anyone living or deceased to dinner, who would you invite? Make a list that includes at least 3 people you'd like to invite to dinner, then use your list to print a message to that person, inviting them to dinner. Okay, who are we going to put in this list? Living or non-living? We're going to say Joe Rogan. I feel like that'd be a fun conversation to have. We are going to include... Who's someone like really smart that I would want to pick their brain? Honestly, I'm gonna say Thor. The pirate software Thor, not Thor Odinson. And then we are going to do one more person. Who would I think would be able to have good conversations with these guys? Honestly, Dr. K. I feel like I'd watch a lot of his videos just for like the interviews themselves because of how he interacts with his guests. I just like the way he conducts those kind of like sessions. I'm not going to call it like a podcast, even though it kind of is, but it's like a little bit more analytical. Okay, now that we got our list of guests, we are going to call this guest invitations. Then we are going to say, or call this variable invitation 1. And then we're going to say that this is equal to f. Dear guess 0 dot title I would like to invite you to dinner as a talk show guest. Okay. And then we're just gonna do what we usually do. We're gonna copy it, paste, paste. Why did that happen? Then we'll just change that. Whoops. Don't even have that many items. And then we'll change these. And then we'll come down here. Call this invitation outputs. Sure. And then we'll just tell it to print invitation 1. We're going to copy the whole thing. And then we're just going to change the values. Now if we save it, run it. What happened here? Dear built-in method title of string object. Did I do something wrong here? Why did it do it like this? What if I just take off these, huh? Oh. Wait. Let's put those back. Boom. 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 Okay. Now let's run it. There we go. Wait. This is still messed up. Oh, that's because this didn't go on the outside. Okay, let's try one more time. Yep, there we go. Now that is our outputs. Okay, let's move on to the next example. Right. Okay, changing guest list. You just heard that one of your guests couldn't make the dinner, so you need to send out a new set of invitations. You have to think of someone else to invite. Start with your program from exercise 3-4. Add a print call at the end of your program stating the name of the guest who can't make it. Modify your list, replacing the name of the guest who can't make it with the name of the new person you are inviting. Print a second set of invitation messages, one for each person who is still in your list. Okay, let's just copy and paste it. Okay. Add a print call at the end of the program stating the name of the guest who can't make it. Okay. So we're going to call this no attendance message. And then we're going to say print. And then we're going to put guess. And then we're going to say position 0. Joe Rogan can't make it. What if we do dot title here? And I think we have to put this in braces if we do that. Cannot make it to dinner. Okay, that's the first step. So now if we save it, run it. Boom, boom, boom. Something's weird. Maybe if we do that, then save it, and then run it. Yep, Joe Rogan cannot make it to dinner. Okay, second part of the list, modifying it, replace the name of the guest who can't make it with the name of the new person you're inviting. Print a second set of invitation messages, one for each person who is still in your list. Don't know why I need to do that. So we are going to say this is a change in attendance. And then we're going to come down here and we're going to say Um, let's see, how do we want to do this? So we can replace it by doing um, this, where we can just do it guess and then give it a position 0 and then say it equals, who are we gonna change it to? Let's just say Hank Green, because he knows about a lot of things. I think it'd be cool to pick his brain. And then we just print this again, so we can come down here and then we can do this and then just change this to say new invitation outputs. So now if we save this and then run this code again, it should print out everything. So dear Joe Rogan, dear Thor, dear Dr. K, Joe Rogan cannot make it to dinner. Dear Joe, oh. I think I have to do this again as well. Oops, my bad. And then we just have to come down here, paste that. Right. So now if we run it, it should not run Joe Rogan twice. Yeah. So after Joe Rogan cannot make it to dinner, we have Dear Hank Green, blah, 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 talk show guest, talk show guest, talk show guest. Cool. Did I ever say talk show guest? I guess I did. Anyway, so that's example 5. Didn't know if that's what was being asked of me, but that's how I did it. More guests. You just found a bigger dinner table, so now more space is available. Think of 3 more guests to invite to dinner. Start with your program from exercise 3.4 or 3.5. Add a print call to the end of your program, informing people that you just found a bigger table. Use the insert to add 1 new guest to the beginning of your list. Use insert to add 1 new guest to the middle of your list, and then use a pen to add 1 guest to the end of your list. Print a new set of invitation messages, okay? So we're going to copy this whole thing. Make a new file. Okay, now we're going to do this. Then we're going to say this is the new table message. And then we're just going to say new table message. And then we're just going to say a new table has been found and we can add more people to the discussion. And then we're just gonna say print new table message. Then we're gonna come down and then we are going to do another change in attendance. So we're gonna put second change in attendance, and then we are going to actually change it. So we're going to use the insert method. So we're going to How did it say to do it? Insert. So you do list dot insert and then you give it a position and then what to insert. Okay. So we are going to say guess dot insert, and then we do the parentheses, give it a position, so we have to do one at the beginning and then comma and then more explanations, and then we're gonna put Joe Rogan back. I think that's it, right? And then we are going to do guess dot insert. So this is a five long thing. So 0, 1, 2. So we're going to insert it at position 2. We are going to add, who else would be like a cool person to talk to, dead or alive? Maybe. Let's do one alive, one dead. So let's do Einstein. And then we're going to do append. So guess dot append, right? That's how you do that. Dot append, yeah. And then someone alive. Who's interesting that's alive right now? Let's do David Goggins. David Goggins. So now we should have more people on the list. And then the final thing to say is print a new set of invitations or invitation messages, one for each person on the list. Okay, so we are just gonna do this and copy it. And we're gonna come down here. And then we're gonna say current invitations. Oh, we should change this to new. So it goes guest invitations, new invitations, current invitations. Guest list, change in attendance, and then second change in attendance. Okay, yep, that works. So we copy this, and then come down, and then all we're gonna do, we're gonna take a single line now. We're gonna come down, paste, paste. And then we'll just change this to 3, and then come down one more time, change that to 4. And then we are going to say current, what was it? Current invitation outputs. Then we're going to come down, same thing, copy and paste it. And then we're going to do a single line and just paste it 2 more times. Change that to say 4, change that to say 5. Ah, forgot to change these. I was wondering why those are grayed out for a second. So now when we save it, it should just give us like a crap ton of lines. Insert. Well, there we go. There we go. So we can save that. Try and run it again. There we go. This is the whole output. Dear Joe Rogan, Dear Thor, Dear Dr. K, Joe Rogan can't make it to dinner, Dear Hank Green, Dear Thor, Dr. K. New table has been found, and we can add more people to the discussion. Dear Joe Rogan, Dear Hank Green, Dear Einstein, Dear Thor, Dear Dr. K. We're missing David Coggins. Did I need to add something to this? I thought I could just guess at a pen. Is that not how that works? Yeah. Guessed at a pen. Did I spell it wrong? No. Did I put something wrong in here? No. Uh-huh. One, two, three, four, five. Right? Let's do print guess first. Okay. What happens if we do that? Yeah. David Goggins all the way at the end. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. I'm so confused. I have 6 people in this list now. 1, 2, 3. Oh, I guess I didn't realize. 1, 2, 3, 4, 5. There's 6. That's that's the issue. I had 3. I added 3 more. Duh. Okay, let's take that out. Then we'll just add one more line of this. Change these values. Add one more of these. Now if we save it and we run it, so we have Dear Joe Rogan, Dear Thor, Dear Dr. K, Joe Rogan can't make it to dinner, Hank Green, Thor, Dr. K, new table has been found, we can add more people, Joe Rogan, Hank Green, Einstein, Thor, Dr. K, David Goggins. There we go. That is all the way up to 6. And I did a good choice when I said we were only going to go up to example 6, because we are at that hour mark and we will be ending this stream here. So I hope you guys found these videos or these exercises and examples useful, so you can see the difference in length of code. So now we're at 55 lines of code. This can be simplified a lot, but we're just doing it this way because it's fast, simple, easy to do. You can shorten this, but not in any way that we have learned how to do yet. So I will see you guys next time. Hui ho.